Alrighty guys, so here's going to be your video notes for today. Basically what we're going to be doing is we're going to be solving a problem, and I'm going to go step by step through the process so you guys understand how to do it. Alright, please make sure that you're writing individual notes because I will be checking these notes at the end of the video to give you guys credit. Alright, so let's begin. The question reads, you are driving on the freeway at a velocity of 35.67 meters per second. You see the fuzz and start to slow down at the rate of negative 4.45 meters per second squared for about 2.9 seconds. What is your velocity after you slow down? For those of you that don't know, the fuzz just means the police. So we went through our initial read through. Okay, I went ahead and I'm going to start listing the givens, but in order to do that, what I'm going to go through is I'm going to go through the question one more time and start underlining the information I think is important. So it says you're driving on the freeway at a velocity of 35.67. So I'm going to underline 35.67 because that's a value with the unit. You see the fuzz and start to slow down at a rate of 4.45 meters per second squared for about 2.9 seconds. So I'm going to underline that too. All right, that's all important information. So I'm going to go ahead and make sure to point those out. Now I'm going to go ahead and start listing the givens. So the first one that I see, all right, change colors here. First one that I see is 35.67 meters per second. Because I see meters per second, I know that that's going to be a velocity. Velocity is equal to 35.67 meters per second. Okay. Next one I see is you start to slow down at a rate of negative 4.45 meters per second squared. Because it's meters per second squared, if I look at my variables there, I know that it's going to be an acceleration. So that's going to be a negative 4.45 meters per second squared. Okay, for about 2.9 seconds, and because that's seconds, I know that's going to be time. 2.9 seconds. Now the question says you're driving at a freeway at a velocity of 35.67 meters per second. So that means you're already at that velocity and then you slow down, right? So if you slow down, you're going to change your velocity from where you were at 35.67 to where you are now. So what we're looking for is the final velocity, right? What is the velocity after you slow down? That becomes my unknown. So if I'm looking for my final velocity, then the velocity in the problem has to be my initial velocity. Okay? So now that we have our givens listed, I'm going to go ahead and just zoom these down a little bit. Let me see here. Okay. So we've listed everything that was given in the question. We underlined the important information. So now what we have to try and do is figure out which formula is going to work for us. Now, we said earlier, right, that we're looking for final velocity. That is our unknown. So, in order to move forward, what we have to do is say, okay, let's take a look at the equations that have velocity or final velocity out front, right? These two have distance or displacement out front. Right? So because they have displacement out front, we know that we can't use those because those aren't set up to find velocity. So just by process of elimination, I can eliminate this formula and I can eliminate this formula. Okay? So we're there. Now we're down to the last two formulas, right? We're down to this formula here and we're down to this formula here. Only one of these is going to work. Now let's take a look at what we have. We have an initial velocity. This one has initial velocity, this one has initial velocity. Okay, we have acceleration, this one has acceleration, this one has acceleration. And we have time, right? This one has time, but does this one have time? It doesn't. So because it doesn't have time, we can't use this formula, and we're left with our last formula standing, which is that one. So the formula that we're going to use to solve this problem is going to be final velocity is equal to the initial velocity plus acceleration times time. All right, this is going to be our formula. Okay, so now I'm going to go ahead and solve the problem. I relisted my givens over here so we know exactly what we're working with, and then the formula we said that we were going to use was VF, final velocity, is equal to V naught, initial velocity, plus acceleration times time. Okay, so there's our formula. Now, at this point, we know what values we have, right? Here's our initial velocity. Here is our acceleration. Here is our time, right? So because the formula is already set up for us, all we have to do is literally just plug everything into the correct value. What that means is you rewrite your formula and just plug everything in. VF, right? We don't know what that is, so we're just going to write VF is equal to, now for the V naught, right? We're going to plug in our V naught value. In this case, it's going to be 35.65 meters per second. Okay. Plus our acceleration, which is negative 4.45 meters per second squared. And that's going to be multiplied by our time, which is 2.9 seconds. We're going to do this one step at a time, right? So we're going to start over here on the left, which is this part right here, right? Now, VO or V naught, there's no operation. So I'm just going to go ahead and bring that guy right back down exactly how it appears, right? Just straight down like this. That's going to be 35.65 meters per second. Okay? There's no operation, so I'm just going to rewrite it exactly as it appears. Now, over here, there is an operation, right? The operation between 2.9 seconds and 4.45 meters per second squared, you remember this is multiplication. So I'm going to multiply these two numbers to give me my new value. So when I multiply negative 4.45 times 2.9, I end up with negative 12.905. And remember, the seconds cancel here. Meters per second. All right. Okay. So all we did was just take this part here, okay, multiply them according to the formula, right? It says you take acceleration and you multiply it by time, and I ended up with this value. Now, once we have those, we can simplify a step further. All right, so let's take it a little bit further. So now the operation says that you're going to take this number, 35.65, and you're going to add it to this number. Remember that when you have a positive and a negative, that becomes a negative. So in reality, what we're going to do is we're going to subtract. So it's going to be 35.65 meters per second minus 12.905 meters per second. And because now they're the same unit, we can subtract, right? So the answer here is 22.745 meters per second is equal to my final velocity. So you're driving along the street at a speed, or in this case, velocity of 35.65 meters per second. You see the cops and you start to slow down at an accelerated or at a rate of negative 4.45 meters per second squared. You do that for about 2.9 seconds. Now, after your slowdown for that amount of time, your new velocity now becomes 22.745 meters per second. And because this is a velocity, remember that the units for velocity are meters per second, and that's exactly what we have, right? You should end up at meters per second. Okay, that's it, guys. All you have to do is read the question, identify the variables, find the correct formula, and solve. Okay, please make sure that you have written down your notes. If you have any questions, let me know. Bring up your notes so I can give you credit. Remember, the video is been uploaded to YouTube, so you can watch it whenever you want. Please make sure that you have your notes, and let me know if you have any questions. Thanks, guys.